representation வந்து ஓகே இல்ல, இது ரெப்ரசன்டேஷன் முடிச்சிட்டோமா இல்ல, இது இப்பதான் ஸ்டார்ட் பண்ணும். ஓகே, ரொம்ப சிம்பிள். செட் ஆஃப் ஆர்டர் பேர்ஸ் அப்படின்றது ரூல்ஸ் ஆஃப் ஃபங்க்ஷன். எக்ஸாம்பிள் 1, 2, 2, 1, whatever we get, ஃபங்க்ஷன்ல இருக்கிற அந்த பேர்ஸ் வந்து போட்டாலே செட் ஆஃப் ஆர்டர் பேர்ஸ். Tabular column, put the values of x and y. இந்த set of ordered pairsல நமக்கு என்ன கிடைச்சதோ, whatever we got in set of ordered pairs, we just have to put the data here. X, value of x, value of y. So for 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36. Just like that, we will just add the data, required data. Arrow diagram, we are already familiar with arrow diagram. And graph, just plotting the graph will be more. What is a vertical line? A curve drawn in the graph represents a function. If every vertical line intersects the curve at most one point, using vertical line test, determine which are the following curve. 1.18, 1.8 BC, A, B, C, B. See here, for this value of x, if I draw a line, I'm getting 2 images. So this is not a function. For this, if I'm drawing a line here, it cuts it in only one place. Right? Vertical line cuts in only one place. So this is a function. For this one, again, it's cutting in 2 places. So this is not a function. Right? Here too, it cuts only in one place. So this is also a function. That is the basic. While doing vertical test, line test, when the vertical line cuts the function, the curve, in only one place alone, then it is a function. If it's cutting in 2 places, 2 or more places, it means that it is having 3 images. So that is not a function. That is the rule for vertical line. Then 1, 2, 3, 4, B is 2, 5, 8, 11, 14. Set of function A to B, given that 3x minus 1. When I substitute x equal to 1, 3 into 1 minus 1, so 2. X equal to 2. 3 into 2 minus 1, 6 minus 1, 5. X equal to 3. 3 into 3 minus 1, 9 minus 1, 8. X equal to 4. 4 into 3 minus 1, 12 minus 1, 11. So for that alone would be drawing. Right? Arrow diagram, 1 to 2, 2 to 5, 3 to 8, 4 to 11. Right? 4 to 11. Next one. Tabular column. For 1, f of x is 2. 2, 3. Right? Tabular column. Set of ordered pairs. It should definitely be inside a set. It should definitely be inside a set of pairs, ordered pairs. Right? Set of ordered pairs. Then graphical form. In graphical form, we will plot the points. This one which we got, y equal to 3x minus 1. Since it is power 1, we'll be getting line. If it's x squared, then we'll be getting a paragraph. Right? It will be a curve. So we are getting a line. So we are plotting the points and moving on. Right? This is the graph. This is what we'll be doing. Then what is the type of function? In this section, we will discuss the following types of functions with suitable examples. 1 to 1, many to 1, on to, and into. Let us assume that we have a cell phone with proper working condition. If you make a usual call to your friend, then you can make only one call at a time. If we treat making calls as a function, then it will be one-to-one. Just like a cell phone, we are just talking to one, right? Group call will not be it will not be a function because you're speaking with 4 people together. Conference is not a function, but one-to-one calling first friend, second friend calling another friend, third one is calling another. All right. So first call, second call, third call. You're calling to each and everyone. So this is one-to-one function. First call you are making to C, second call you are making to A, third call you are making to B. All right. A function f from A to B, whenever you get this, you have to read it as f function from A to B is the right way of reading it. It's called one-to-one function if distinct element of A have distinct image, unique separate image. Okay, unique separate image. No images same. Distinct A, the elements of A should definitely it should be distinct, or else it's not a function. And each element of A should have a separate unique image. No other element of A should go to the same image. All right, that is one-to-one function. Then equivalently, if all A1 comma A2 element of A, f of A1 equal to f of A2 implies A1 equal to A2, then the function is called one-to-one function. A1 always goes to A2. If I am putting A4, it will be going to the other function. Right? So illustration, A equal to 1, 2, 3, 4, B equal to A, B, C, D, E, function 1 comma A, 2 comma B, 3 comma D, and 4 comma C. Fig 1.22 shows the 1.22 shows the different element. You can just map it, arrow diagram, it will not be a problem for you, right? Then this one, 1 to 1 to B, and 2 to B, 3 to C, 4 to E. So here from 2 unique A, 1 image is there. So this is a function, but not one-to-one function. This is a function, but not one-to-one function. It is also known as many-to-one function. That's what we'll be seeing here. If a theater complex 3 films, F1, F2, F3 are shown, 7 persons, P1 to P7, arrived at the theater and buy ticket as shown in. If the selection of film is considered as the relation, then this is the function which is many to one, since more than one person may choose to watch the same film. There are 7 people buying tickets for different movies. Automatically, some people will be viewing one movie, some will be the second, and some will be the third. So many to one function, right? Many to one function. Then a function from A to B is called many to one if 2 or more elements of A have the same image in B. In other words, a function f from A to B is called many to one if f is not one-to-one. Illustration 11. A equal to 1 to 3, 4. B equal to A, B, C. F 1 to A, 2 to A, 3 to B, 4 to C. Right here, we can see that 1 and 2 have same image. So this is many to one function. What is an onto function? In a mobile phone, assume that there are 3 persons in the contact. If every person in the contact receives a call, then the function representing making calls will be onto. 3 persons are there, everyone is getting a call, everyone are speaking. So what is the rule? Onto function, that is range is equal to codomain. Range is equal to codomain, then it is onto function. Right? There is no extra P4 here, which is not getting mapped. So this is onto function. In other words, every element in the codomain B has a pre-image in the domain A. And onto function is called a surjection. Surjection. Okay? Very important. You'll be getting these kind of things in 1 mark. Onto function is also known as surjections. Okay? That is, for onto function, codomain equal to range. Codomain equal to range. Range of function equal to codomain. Illustration X, Y, Z, and LMN. Here we can see that each has a unique image and also range is equal to codomain. So we can say this as 1 to 1, 1 to 1 onto function. Right? 1 to 1 onto function. Similarly, in home appliance showroom, the product television, air conditioner, washing machine, and water heater are provided with 20% discount and as New Year sale offer. If the selection of the above product by the 3 customers C1, C2, C3 is considered as a function of the following diagram, will represent an into function. That is, each and everyone selecting one, no one has selected air conditioner. Here, the range is television, washing machine, and water heater. But the codomain is all these 4. So codomain not equal to range. Then it is an into function. All right. Then it is an into function. During winter season, customers usually do not prefer buying air conditioner. Here, air conditioner is not chosen by any customer. This is an example of into function. So what we can say, a function f from A to B is called an into function if there exists at least one element or in B which is not the image of any element of A. Or else we can otherwise say any element of B doesn't have a pre-image. All right, that is also true. Right, doesn't have a pre-image. That is, the range F is a proper subset of codomain, not the full codomain. It will be a subset. All right, it will be a subset. In other words, function F from A to B is called into if it is not onto. If it's not onto, definitely it is an into function. Right? Here, y doesn't have a pre-image. So this is an into function. Bijection. Consider the circle whether each letter of the English alphabet is changed from inner portion to the letter in the outer portion. Thus, A to D, B to E, C to F, Z to C. We call the circle as Cipher Circle. In this way, if we try to change the word hello, then it will become Khor, Khor. Now, using the same circle, if we substitute for each outer letter, the corresponding inner letter will be back, the word hello. This process of converting from one form to another form and receiving back the required form is called bijection. All right. This process is widely used in the study of secret codes called cryptography. All right. All the informations, secret informations, or very, very important informations are sent as a cipher. All right. It is a secret message only meant for a certain kind of people. They would be knowing the unlocking code. With that unlocking code, they can get the result back, what the message is. Okay. So, in Apple iPhone, they say it is very secretive, isn't it? Because the user has a specific code and the person to whom is sending message or anything can't be ciphered easily unless the person who sent it allows it. They can't cipher it. That's why it is user friendly. But think about this Android. It is easily breakable. Suppose if you're searching for a book, typing a book in Google search engine once. From that point onwards, there'll be ads of books. If you tried for a cycle, price of cycle, automatically they'll be showing offers on cycle as ad. So they are using all our information and selling it as an ad. Okay. So this thing is happening again and again. If I go into one thing also, automatically I'll be getting ads regarding that. Automatically there'll be ads regarding. So how to use, what to use, where to use, and what kind of modes I want. Automatically it will be showing the same. Okay, we have to show in this. Then only we will buy this. Attract people and make them buy. Okay. The same thing happens here also. The same thing happens here also. Like this page. If I search once, cricket, Dhoni, all about Dhoni will be there again and again. If I searched about a book, again they'll be showing book. All right. They will use our data. They will use our data clearly without any terms. They will use our data clearly. This is the fundamental. This is what's happening here. Okay? So we go back. So that is cryptography. A lot of people who are strong in mathematics and alphabets, they can opt for these kind of. They will enjoy puzzles, mazes, something, some kind of food for the brain. Some people, they don't want to use their brain at all. They just want to go, sit, do their work, and come. Okay? There will be a difference there. Okay? So one-to-one and on-to function, bijection. All right, bijection, both together. All right, that is one-to-one, and it is also on-to function. Then here, one-to-one, but into function. One-to-one into function. This is many-to-one onto function. Many-to-one onto function. Okay. So that's what they want to say. What is an onto function? If range is equal to codomain. If range is not equal to codomain. Okay. Horizontal line. Previously, we saw vertical line test, isn't it? Now we are going to do a horizontal line test. Okay. What will this horizontal line test show? A function represented in a graph is one-to-one if every horizontal line intersects a curve at most one point. That is, a horizontal line is cutting at only one point, then it is one-to-one function. If it's cutting at many points, then it is many-to-one function. That's it. This is one-to-one. This is many-to-one. Many-to-one. This is one-to-one. This is one-to-one. Okay. So the curve represent a one-to-one function as a horizontal line makes the curves in only one point. So that's how we use vertical line to check whether it is a function. If it cuts in only one place, then it's a function. If it's cutting in more than one, two or more, then it is not a function. Horizontal line test will say whether it is a one-to-one or many-to-one. Okay. It won't say whether it is onto function or into function. It will say many-to-one or one-to-one. Right? That's what it will show. So 1 to 3, 4, 5, 6, 1 to 4, 2 to 5, and 3 to 6 be a function. Show that f is 1 to 1, but not onto. Yeah, f is 1 to 1. After drawing the arrow diagram, we can see that it is 1 to 1. The codomain is 4, 5, 6, 7, but the range is 4, 5, 6 only. So range is not equal to codomain. Hence, it is not an onto function. It is an into function. 1 to 1 into function. Right? Then -2, -1, 0, 1, 2. A is given. Function is an onto defined by x squared plus x plus 1. X squared plus x plus 1. Then find b. We have to find b. They are given it as an onto function. So everything should have a image. The range and codomain are equal. When I substitute 2, I'll be getting 3. When I substitute -1, I'll be getting 1. When I substitute 0, I'm again getting 1. When I substitute 1, I'm getting 3. When I substitute 2, I'm getting 7. So 3, 1, 3, and 7. 3 is already getting repeated. We already know it is an onto function. So range and function is same. If I have to draw the diagram for this, arrow diagram for this, it will be like this. -2, -1, 0, 1, 2. Here we have 1, 3, 7. -2 to 3. -1 to 1. 0 to again 1. 1 to 3. 2 to 7. So this is many to one function and also an onto function. By notifying this is an onto function, we can easily say that b is equal to range, and you'll be getting this. F be the function, natural number to natural number. All right. We define by f of x equal to 3x plus 2. X element of n. Find the image of 1, 2, 3. When I substitute 1, 2, and 3. 3 into 1. 3 plus 2, 5. When I substitute 2, 3 into 2, 6 plus 2, 8. 3 into 3, 9 plus 2, 11. Okay? Those are the images. Find the pre-image of 29, 53. So pre-images, we have to find x. All right, x. So what I will do, 29 equal to 3x plus 2. All right, 29 equal to 3x plus 2. So when this 2 comes here, it becomes 29 minus 2 equal to 3x. So 3x equal to 27. X equal to 27 by 3, 9. All right, 9. Then 53. For 53. 3x plus 2 equal to 53. When this 2 goes here, 3x equal to 53 minus 51. This is 17. X equal to 17. 51 by 3, 17. So this is the pre-image. Right? Pre-image. See, we got this. We got the image. Since different elements of n have different image in the codomain, the function is an one-to-one function. See here, all this 1, 2, and 3 are having different images, unique images, and 9 and 17 is also having unique images. So everything is having a very unique image. So it is a one-to-one function. And it is a into function. One-to-one into function. Not all the numbers getting mapped. Okay. See here, when we substitute 1, it is 5, then 8, then 11. 3, 3, 3. So what about 6 and 7? It doesn't have a pre-image at all. Okay. 6 and 7 doesn't have a pre-image at all. So this is 1-to-1 into function. 1-to-1 into function. All right. That's what will be right. They'll be giving a lot of things, but we can make it simple. Okay. This is what given, this is what it is, and we got the answer. This is a good one. A forensic scientist can determine the height in centimeter of a person based on the length of the thigh bone. We went through the arm, isn't it? Now we are going through thigh bone. All right. They usually do so using the function height equal to 2.47b plus 54.1. All right. 54.10, where b is the length of the thigh bone. Verify the function h if 1-to-1 or not. Also find the height of person in the length if the length of the thigh bone is 50 centimeters. Find the length of the thigh bone if the height of the person is 147.96 centimeters. Right? Vice versa. We have to find. Okay, definitely for each value of b, each value of thigh bone, I'll be having different value of height. So it is a 1-to-1. All right. 1-to-1 function. Number one. Yeah, it is a 1-to-1. For the unique value, only unique height will be there. There will not be same height for different length of thigh bones. One. Next, find the height of the person whose thigh bone is 50 centimeters. So substituting 50 here, 24.7, 2.47 into 50. It becomes 24.7 into 5. All right. Applying that, we'll be getting the result. All right. Applying that, we'll be getting the result. Then, to find the length of the thigh bone, vice versa. 2.47b equal to 54. Okay, this 54.1 will be coming here. I'll be subtracting it and dividing it by 2.47. You'll be getting the answer. Okay. When you make it simple, you can easily get the answer. Right? When you make it simple, it will be easy. Always it will be very, very tough. Right? So, activity. Check whether the following curve represent a function. If the curve, in the case of function, check whether it is 1-to-1. Use vertical and horizontal lines. Is this a function one? First one. Is this 1-to-1 or many-to-1? Because it is cutting at only one place. So this is a function first. We found it is a function. And when I put a vertical line, I could see this line is cutting a lot of places. So this is many-to-1 function. Yes, it is a function. It is a many-to-1. Then this one. All right, this one. It is cutting in only one place. It is cutting in only one place. All right, one place. So it is a function. And the horizontal line test, 1-to-1 function. Here also it is cutting one place. And horizontal line test, 1-to-1 function. It should travel all over the line. All right, not only here, it should travel all over the curve. And automatically we could see that this is also a 1-to-1. Then this one is not a function at all. It's cutting in two places, vertical line. Here also it's cutting in two places. All right, a lot of places. So this is not a function. But this one would be cutting in only one place. So it is a function. When I go for vertical horizontal line test, I could see this line is cutting in two places. So this is many-to-1 function. Actually, the formula would be like this. y equal to modulus of x. If I put -1, I'd be getting +1 only. Modulus of x. Y equal to modulus of x, where we'll be getting this. Right? This we like. Right? We like. So we have some special functions, special case functions, constant function. In constant function, all the elements of A have only one image. All the elements of A would be having only one image. Then that is a constant function. Identity function. All the image, both image and pre-image are same. 1 to 1, 2 to 2, 3 to 3, 4 to 4, -1 to -1. If all the image and pre-image are same, then it is identity function. Real valued function, it is a continued function. Right? It will not be having values like 1, 2, 3. All the values from -infinity to +infinity would be between that. Right? So we will go into that. A function a to b is a constant function if the range of f contains only one element, that is f of x equal to c, a constant. So whatever value of, there is no x here. So always it will be pointing to a constant. If I put x, f of x equal to c, f of x equal to 3, automatically it will be 3. So a to a is defined by f of x equal to x. So f of 1 equal to 1, f of 2 equal to 2, f of -1 equal to -1. Okay? For constant function, we saw the f of x equal to c, any constant, maybe 5, 6, c, any constant. For this, f of x equal to x. So it would be forming an identity function. Here, a equal to abc, f ia equal to a comma a, b comma b, c comma b. That will be if I'm working with a right, this line will be providing that 1 comma 1, 2 comma 2, 3 comma 3, minus 1 comma 1, minus 2 comma minus 2, minus 3 comma minus 3. This line will be giving an identity function. Okay, what is a real valued function? A function f from a to b is called real valued function if the range is a subset of the set of all real numbers. Subset of all real numbers. All real numbers. It may be 1, 2, it may be minus 100 plus 1 lakh, all real numbers. So it is a continuous function. 1.1, 1.2, 1.001, all the numbers would be there. Then it is a real value function. Okay, true or false? All one-on-one function is onto function. Okay, thank you. False. It can be an onto function and it can be an into function. Good, false. No one-to-one function. A has 4 numbers. B has only 3. So definitely one should be having at least 2 images. All right. 2 would be going at least to 1. Example here 1, 2, 3, 4. Here A, B, C. If I'm mapping 1 to A, 2 to B, and 3 to C, definitely I have to map this. So it should be with anyone, isn't it? So it cannot be one-on-one function. Hence it is true. Why you said false? You didn't see that? No. See, this kind of error is where you will be losing marks. You'll be getting maximum marks. You'll be losing because you're not viewing it uniquely. Right? Each and every word can differentiate. All onto functions are one-to-one function. False. All onto functions are one-to-one function. This is an onto function too. Is this a one-to-one function? Right? Imagine, right? Imagine. No. Then there will be no onto function from A to B when n of A equal to 4, n of B equal to 5. Why? How can we have an onto function? Yeah. That's why you have to imagine properly. A, B, C, D. Here we have 5. 1, 2, 3, 4, 5. Example only. 1, 2, 3, 4. Even if it's 1 to 1, we'll be having one element free. Okay. There will be no onto function from A to B. Yeah, it is a true. So the way you're perceiving that question is where you're missing. That no. A lot of people, their mind will say it is an onto function. They will definitely miss that no, not. All right. Not an into function, then it is an onto function. we can easily twist our words. All right. Is a onto function, not an into function is also an onto function. All right. Not a onto function is a into function. So all these four can be in combination and they will try to confuse. But our mind should be free. If you're not convinced with your result, draw an example diagram and see. You will get the result. All right. If F is a bijection from A to B, N of A equal to N of B. N of A equal to N of B, bijection. Right? If N of A equal to N of B, then F is a biject function from A to B. Okay. Right? All constant functions are bijection. Okay. All right. What is a bijection? One-to-one and onto function is known as bijection. Good. All right. N of A equal to N of B. Is it a onto function? One-on-one, one-to-one onto function. How can we say it is an one-to-one onto function? Because each element will match. They didn't give such things. Each element is matching, having a unique image. They didn't say that at all regarding this too. They are given N of A and N of B. N of A is 1, 2, 3. N of B equal to A, B, C. I can map 1 to A, 2 to A, and 3 to A also. All right. You can say that 1 to A, 2 to B, and 3 to C. All right. We can't predict with N of A equal to N of B alone, it is a bijection. All right. If they are provided with range, range is also N of B. Then we can say your point is right. All right. N of A equal to N of B and N of B equal to N of range. Then it is definitely true. One-to-one onto function bijections. But here, this is not. Both are false. I let you do it. Okay. You're having some idea what your perceived is N of A equal to N of B, automatically one is going to one, one is going to one. Right? They are just giving the number of terms alone. They haven't given any other extra data. So example like this, I can give you something. 1, 2, 3, A, B, C. What you perceived as 1 to A, 2 to B, or 3 to C. 1 to 1. Right? What I perceive as 1 to B, 2 to B, and 3 to B. This is also possible, isn't it? Here N of A is 3, here N of B is 3. But the range is 1. Range is 1. If the range is equal to N of B, then definitely what you perceived in your mind is true. They didn't give that. That's where you have to be strong. Right? If they're given some extra data regarding it, well and good, fine. If not, we can't proceed there at all. All constant functions are bijections. No, it is not. All constant functions are many to one into functions. Many to one into function. Bijection is 1 to 1 onto function. So we can't say this. This is also false. 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 Okay. Example. Let f be the function r to r defined by f of x equal to 3x minus 5. Find the values of a and b given that a comma 4 and 1 comma B belongs to F. Okay. They are saying that A comma 4. If I substitute a value of X, I'm getting the result as value of X as A. I'm getting the result as 4. Okay. So 3A minus 5 equal to 4. When it goes here, all right. When it goes here, it becomes plus 5. So 3A equal to 9. A equal to 3. Lot of people, what they do, they'll subtract it. They'll subtract it, put 1 here. Then they'll be bringing this 3 down and say it as 1 by 3. Okay. These kind of things are happening again and again and again. In a lot of places, this one is repeating. So we have to be sharp with the question. Here, if the value of X is 1, F of X would be B. So when I substitute X equal to 1, F of X equal to B. So 3 minus 5 is B. That is 3 minus 5 is minus 2. Okay. Here, like we already decided, I already told you yesterday regarding this sum. It's a real number. R to R. Next, 2x plus 7. 2x plus 7. If x lesser than minus 2. That is until minus 1. Minus infinity to minus 1. We should use 2x plus 7 as a function. If it's greater than or equal to minus 2, that is minus 2, greater than or x is greater than or oh sorry, this is lesser than minus 2. Minus 3. Until minus 3, we will be using this one. Here, from minus 2 to 2. Minus 2, minus 1, 0, 1, 2. X is greater than or equal to minus 2. So minus 2, minus 1, 0, 1, lesser than 2. Sorry, lesser than 3. So 2. Here, greater than or equal to 3. From 3 onwards, any number. We have to use this function. So f of 4. 4 will be here. So 3 into 4 minus 2. Right? F of minus 2. Minus 2 is here. So minus 2 whole square minus 2. Then 4, 2 into f of 1. F of 4 is this one. 2 into f of 1, we'll be using this formula, 1 squared minus 2. Then applying that, we'll be getting it. Here for 1, then for 1, this one. For 4, this one. For minus 3, this one. Get the data and we just have to supply it in each and every place. This sum looks very big, but it is very, very simple. Right? They are trying to explain things. But what is funny is, a lot of people won't be understanding the explanation. If it's just numbers alone, equation alone, it would be easy. The explanation will be really tough. For students, reading and understanding that explanation will be difficult. Use 1, use 2, use 3. They'll be confusing. So that question will look quick. All right. Okay. Which one is function? Which is not a function? Yeah, not a function. Function. Not a function. Function. Good. All right. A to B represented by x by 2 minus 1. So when I substitute, sometime they'll be giving B to A. Be careful. We have to substitute B and get A. B would be here, A would be here. A lot of people have this idea. Okay, first one will be A, second one will be B. They will proceed just like that. But the question will be B to A also. Right? Be careful with that. So when I substitute 2, all right, I'll be getting separate points. I have to put it in set order, table, arrow diagram, and a graph. I don't think you would be having any problem with this, isn't it? Okay, you can proceed. Here they are given ordered pair, set of ordered pair. From this, we have to do arrow diagram. So 1, 1, 2, 3, 4, and 5 would be A. And 2, 2, 2, only 1, 2. Okay, 3 and 4 will be B. From 1 to 2, 2 to 2, and 3 to 2. From 4 to 3 and 5 to 4. All right. A graph. Show that the function f from n to n defined by f of x equal to 2x minus 1 is 1 to 1, but not onto. 1 to 1, but not onto. Each value of natural number would be having a specific, unique image. Okay. So if I substitute, it's a all natural number. Okay. 2 into 1 minus 1, 2 minus 1, 1. If I substitute 2, 4 minus 1, 3. If I substitute 3, 6 minus 1, 5. So number 4, sorry, number 2 and number 4 doesn't have a pre-image. So range is not equal to codomain. Hence, it is not an onto function. But definitely, each and every number have a unique image. So it is a one-to-one function, but it's not an onto function. Okay. Show that the function f of m equal to m squared plus m plus 3 is one-to-one function. When I substitute 1, I'd be getting 1 plus 1 plus 3, 5. When I substitute 2, I'd be getting 4 plus 2 plus 6 plus 9. Okay, 5, 9. Then when I substitute 3, 9 plus 3, 12, 12 plus 3, 15. How much it is getting added? Here it is 4. Here it is 6. Right? So there is a difference also. Big difference. When I substitute 4, it will be 16 plus 4, 20, 20 plus 3, 23. Now the difference is 8. So this is also a sequence. It is following a systematic group. First one is plus 4, second one is plus 6, third one is plus 8. Next one, definitely it will be plus 10. Right? So these kind of patterns is what we have to learn. What you have to learn is these kind of patterns. When you understand these patterns, you will be getting into this. Why I'm saying, repeating this is because these kind of patterns you're going to get it in next chapter. All right, sequence and series, arithmetic progression, geometric progression. There'll be different questions. So we had to be awake. We had to be strong there. Right? In each of the following cases, state whether the function is bijective or not. Justify your answer. Not bijective. Why? No, it's an into function. Yeah. Right. Here. Okay. It will be having many to one also. Right? Many to one also here. If A is minus 1, 1 and B is 0, 2. A to B is defined by f of ax plus b is an onto function. Find A and B. It's an onto function. So it is an onto function. If I substitute minus 1, I may get 0. All right. If I substitute 1, I may get 2. Or else if I substitute minus 1, I may get 2 and 1, 0. There are two options here. Okay? So that's what I'm going to do. When f of x equal to 1, minus 1, it is minus a plus b equal to 0, or f of 1 equal to, when I substitute 1, a plus b equal to 2. So when I add it, this get cancelled. 2b equal to 2, b equal to 1. 2 by 2, 1. Okay. When I substitute b equal to 1 here or here, anywhere. When I substitute b equal to 1, a plus b equal to, in place of b, I have to write 1. It is 2. So when this 1 goes here, a equal to 2 minus 1, it is also 1. So the format is f of x is x plus 1 format. All right, x plus 1, a equal to 1 and b equal to 1. This one we already saw. If it's x is greater than 1, use this. If it's between minus 1 to plus 1, use only constant 2. If it's between minus 3 to minus 1, use this one, right? So f of 3 is greater, so I'll be substituting here 3 plus 2, 5. F of 0 is here, so definitely it's 2. So minus 1.5. 1.5 can also be written as 3 by 2 minus 3 by 2. Right? We have to know these values about these because if you convert into 3 by 2, it will be easy for you to cancel. Easy for you to cancel. That's why this is really, really important. Okay. The next one. This is a function. The function itself will be closing minus 5 to 9. Okay. Minimum would be minus 5, maximum would be 9. Apart after that, there will not be any function. After that, it is 0. Before this, it is 0. After this, it is 0. Right? From minus 5 to 2. Minus 5 to 1. Okay. Minus 5 to 1. This means if we put like square bracket, this means all the numbers in between. All the numbers in between. Let it be 1.1, minus 1.1, minus 4.5, minus 4.00005. All are real numbers. For all those numbers, we have to use this one. Then if it's 2, close, 2 to 5, we can write this as 2 to 5 also. Right? For this, for 6 to 9, this formula. We just have to apply the formula, get the result, and distribute. Okay? So that's what we'll be doing here. This is the real formula. This is the real formula from science. Okay. The distance s an object travels under the influence of gravity is t seconds. In t seconds is given by st equal to half gt square plus at plus p, where g is the acceleration due to gravity, which is equal to 9.881. Generally, we'll be using 9.8. A and B are arbitrary constants. Verify whether the function st is 1 to 1 or not. If I substitute t equal to 1, what it would be? T equal to 2. Definitely it will be having a specific value. All right. It can't be negative. T can be 0. If t is 0, then st equal to b. That is distance is b distance. Already starting from a mistake, b has 10 meters. Okay, it's starting from 10 meters. All right, 10 meters. And it goes on. The function T, which maps temperature to Celsius into temperature in Fahrenheit, is defined by Tc equal to F. F equal to 9 by 5c plus 32. Then find T equal to 0, 28, minus 10. And for what value of C, we will be getting 212 equal to 9 by 5 C plus 32. A lot of people will take this 5 immediately. No, first we have to subtract this 32, then only we have to multiply this 5 and divide by 9 to get this. Okay. So the temperature when the Celsius value is equal to the Fahrenheit value. When will the Celsius value be equal to Fahrenheit value? Is that possible? Why not? Just try. Why it's not possible? See here, Celsius equal to Fahrenheit. So F equal to C. C equal to 9 by 5 C plus 32. So when I take the C here and 32 here, it becomes 9 by 5 C minus C equal to minus 32. So when I take C as common, it becomes 9 by 5 minus 1. So 9 minus 5 by 5, 4 by 5. That is 4 by 5 C equal to minus 32. Minus 5 goes here, 5 goes here, and 4 goes here. So C equal to minus 32 by 4 into 5. 1 times 8 times. At minus 40 degrees Celsius, both Fahrenheit scale and Celsius scale is same. Okay. You just have to apply the concept. Just have to apply. Okay, they are given this from temperature. Actually, that is the real formula for converting Fahrenheit to Celsius and Celsius to Fahrenheit. All right. When we want to convert Celsius to Fahrenheit, now it is 32 degrees Celsius, isn't it? What's the temperature now? 29 degrees Celsius. All right. Now it is 29 degrees Celsius. So if I want to convert into Fahrenheit, F equal to 9 by 5 into 29. Let's take it as 30 for simple calculation. 32. 6 times. 54 plus 32. 86. Now it is 86 Fahrenheit. The same Fahrenheit can be converted into Celsius. That also has a formula. F minus 32 into 5 divided by 9 gives C. If you want to find C, it is F minus 32 divided by into 5 divided by 9. This one would be giving. Okay. Okay. Very, very simple and effective way to understand. Okay. There are numerous ways to find this formulas too. Actually, this is the real problem. Real problem. The temperature which we use in hospitals are in Fahrenheit. The weather temperature will be in Celsius, degree Celsius. And science, it says temperature in Kelvin. All right. 0 degree Celsius is 273.15 Kelvin. In your paper, you will be getting 273 alone. And the exact value is 273.15 would be the exact value. So when you understand the fundamentals, you will be getting that result. That's what we do here. Okay. This will be fine. To complete this, I want you to read this one. If it's possible for you to work. No, leave it just like that. Okay. You complete this. Until this you complete, I will send I'll give you smart work class printout. You work on that printout. Addition, subtraction. It needs proper time to work on that notice. Then it will be ended. Are you okay now with those questions? If you find